Assume copper has a charge carrier density of 8.5 times 10 to the 28th free electrons in every cubic meter of the material. How many free electrons are in 0.01 meters of copper wire if that wire has a radius of 4 millimeters? Let's take a look at the geometry of this. The wire is going to be a cylinder shape where the length is 0.01 meters. We also see that the radius is 4 millimeters. And we have the charge carrier density, 8.5 times 10 to the 28th. All right, one option we have here is to find the volume of this wire. And the formula for this will be the cross-sectional area A times the length of the wire. This is the cross-section. And we just want to multiply that circle area times our delta x. So we'll use the formula for area of a circle. And let's plug in. The volume is 5.03 times 10 to the minus 7 cubic meters. At this point, we want to try to find out how many free electrons are inside this wire. Keep in mind that this is not all the electrons inside the wire. We're only looking for the ones that are free to escape from their nuclei. In any copper atom, there will be 29 protons in the nucleus. And then around that nucleus, there will be electrons in several different energy levels. But the electrons that are on the inner shells are not the ones that are going to be free to escape. We're just looking for electrons in the outer shells that can escape. All right, so a formula we can use for this will be big N equals little n times delta V. Big N stands for the number of free electrons. Little n will be our free electron density. And then we just have to multiply that density times the volume of our wire. The answer is 4.3 times 10 to the 22 free electrons. These will be the electrons that are involved in conduction of electricity.